Hello and welcome, Phil here. So what I want to have a look at in this video is using a dedicated flashing tool to load the code onto the MCU. So if you searched for Flash and MCU and you were looking for the Flash and the Marvel Cinematic Universe, you may be in the wrong place. However, stay around while you're here. So why would you want to flash code? Obviously, you need to get your program onto it, but you have been probably flashing your code using Visual Studio Code as part of the interface for that. For example, when I load this up here now, for example, yeah, you've probably been using this either this flash build flash monitor button or the flash button itself, and that's perfectly fine and good and dandy and nothing wrong with that. Especially if you're going through a development cycle, because you're going to want to be flashing code, testing code, running debuggers, flashing code, testing code, and so on, and making changes. So you'll probably be doing it from the environment. But there does come a time when you don't want to have Visual Studio Code. You want a simple tool to load the binaries, the executable files onto the microcontroller. And this is various reasons why. You might have a device in production or out on site and it's in test, and you need to travel there with a laptop, and you don't necessarily want to have your full development suite on that. You want to just have a simple program that you upload your binary. You might have a storage area on Google Drive or somewhere that you keep your binaries that are out in the field, and what's on your Visual Studio Code is your development branch. And then well, these binaries are version 1.3.4 or whatever, and they're on my drive, and if I need to flash a micro to what's actually out in the real world, I'll just flash it using that. So it breaks the having to have your PC that you're uploading the code onto to your PC that you're doing your development work. Might be a situation where someone else is putting the code onto the microcontroller. You might have somebody who looks after the hardware side, and they want the ability to just flash it up, and you don't necessarily want to give them your code, not because of IP. If they're in the same if they're working with you, that shouldn't be an issue, but it might be a case if you don't want to give them access, they'll have to use Visual Studio Code. There's a couple of steps to it. You want to just give them a simple tool. Well, there is such a simple tool that lets you program up your microcontrollers, and it comes from Espressif. So if we do a search from Espressif, we can see, so I've just done their esp-idf flash tool, and I came back with this one, which was this tool's from Espressif. And if we go into that, we will see there was actually a new one. When I looked this morning, there was a new one. So I had been using 3.9.3, and there's one here, 3.9.4. Okay, I do only see that there's a Windows variant. So if you're doing this on Linux, either you might have to, I don't know if it works in an emulator or whatever, or if there are tools out there for it. So you need to download it, and once downloaded, it just downloads as a flash file, not flash file, it downloads as a zip file. And sorry, I'm just getting it up here. I've just moved it to a folder then, and so it is, you can see here was the previous one, here's this one, 3.9.4. all you have to do is you just extract that, and I've extracted it to here, and when you go into here you get a load, some DLLs, some binaries for itself, which are test ones I believe, and the application itself. Now the first time you run this, you will get the usual warning of this is an unsigned, you want to run it. Yeah, I mean, I've downloaded from espressif.com. I'll put the link in that to the in the video from where I got it from. So yes, you will get a question, do you want to run it, and it'll run from there. And it's a very straightforward tool, which I'll just open it up there. So it runs up this command line, then it gives you a prompt of what device you want to use, because you can see this can even program the E20, the esp8266, and you can see there are the different flavors of the ESPs. Now I do notice that this one, the C6, wasn't on the previous release, so they've probably added in this micro. So for this test, I'm going to be using the S3. So you'd select S3. I'm going to come back to this develop mode in a minute, and this load mode UART or USB. Well, UART is the one I'm going to be using, which is the one, if you've been using the esp-idf program tool, Visual Studio Code, this is the way you'll want to do it. And these are the default settings. So when you go into it, you get this file menu loader here, and you get some settings. So there are some files you need to point to and the address at where they're going to be written in the micro, and then you hit start stop arrays and the baud and the COM port. So what files do you need? The documentation isn't very intuitive, so that's why this video is here. So I'm just going to close this down and I'm going to go back to Visual Studio Code. So in Visual Studio Code, don't worry about what this application is. It doesn't really matter. I'm downloading it to an S3. So what I want to do first is I would normally build a new test. So I'm going to flash this device and it's going to open up the COM port. And there's an important reason why I'm flashing this device apart from testing the code. And I'm not using the build flash monitor because I want, when you use the build flash monitor, this output here is lost, it's dumped, and you get the monitor. We need this information here. And the reason we need this information here is this is using a built-in flashing tool. You can see here's the command here. So it's executing this command here and it's esp tool, Python application, same COM port for the board it's using. And there's a couple of flags there set. The mode, which is DIO, the frequency is 80 megs, and these ones are all very important. So what you need to do at this point is open up Notepad or a editor of your choice, and there are certain files we want to record. So what they are is the boot speed, the SPI mode. We don't need a flash size. We need the bootloader bin and the offset, the partition table bin and its offset, and the project that we're flashing and its offset. Now I have noticed that if you use an esp32 S1, the vanilla one, the original one, this offset was 1000 hex. So this will change. So there's huge flexibility in the Espressif chips. You can change the size of the partition tables, you can do all sorts of fancy stuff and move stuff around to optimize your code space, or if you want to have different partitions for, say, a file system or whatever. So we need to load them in. So if we have made a custom partition table, we need to point at where it is and where that and all these sort of parameters with it. So the S3 seems to use this as the default, but we don't have to guess because that's the reason we flashed the chip, is so we can get this information. So you can see here it says flash frequency 80 megahertz. So record that in your notepad. It says the flash size, but you don't really need that. It says the flash mode, which is dual. It could be dual or quad. If you get these wrong, you can usually mess around. You can usually try dual at 40 megs, quad at 40 megs, quad at 80. Here's the really important one. It says the bootloader binary. So we need a bootloader binary. So it's going to tell us what binaries it's actually loading up. So it's bootloader binary, and its offset is 0x0. The next one is the application itself, and the application's name is binary, and you can see it's just at 10,000 hex, and it's this application. And then the next one is the partition table, and you can see that this is at 8,000. And you also notice that both the partition table and the bootloader are in folders of their own. So the bootloader binary is in bootloader, and the partition table binary is in partition table. So we note all those down. Noted them down here. Bootloader bin, and then this one is in partition table bin. Well, it's in. I haven't made a note of the path there because I actually am so used to doing these. So where are those paths? Well, if we go over to our main code and we go to our build folder here, we can see. So this is the root. So in it was Hovion. So if I look down here, and there is the binary, and then I look, the next one was the bootloader, was in bootloader, a folder called bootloader, and there it is. Where is it? There it is, bootloader binary. And we also have, the last one was partition. So we should have a folder here for our partition table, and here it is, and there's that binary. So if you want to open up that folder in a quick, easy way, you can just right click on the build and you can just go reveal in File Explorer and it will open up. So there's the build folder. There is our binary, wholly owned. There's our bootloader binary. And also in here is our partition table binary. Now, there's one thing you may have noticed. There is also an elf. So you can see if I go back into build and we go to the application name, there's an elf there. So it doesn't use elves. What is elves? Elves are a file that usually embeds in its header the location of the binaries and the offsets. So if you're used to flashing with an elf, you usually just flash the elf code. And the elf actually contains the link to the binary and the offsets and that. However, this tool doesn't use it. It's interesting that it compiles with the elves, but the tool from Espressif uses the binaries. So we need to make a note of those values. And as I said, that's why we run this file here, because this gives us all the information we need for the next step. Now, I'm just going to show you here. I'm not going to use the monitor, the normal monitor we use. I'm using a standard ASCII serial port device called, I think I gave a link to this before, it's called Smart TTY. Again, I'll post it. It's freeware, and it's from people who make Code GDB. And it's quite a nice little handy tool. So I'm going to open up the serial port, and the reason I'm going to do that is I just want to show you what the application looks like when it boots. So you get the usual green, and then there's it's dumping a statement to the screen, and there's some configuration. This is just so that when we flash the code, if we get to this stage, we know it's done right. So I'm just going to close that port down and move that off screen. So hopefully, right. Okay, so do we need this anymore? No, we don't need this anymore, unless we haven't noted these, which we have. So I'm going to close that down. And here's the tool. So we open up the tool again, and it opens up this command line. It gives us prompts, and we go, this is an S3. It's true. We're still going to development mode. We will have a look, as I said, what the other option is. So we can see here, here's our table, and this is where you pull up your notepad of your settings beside you, so that you have them to hand. And our flash was 80 DIO. I'm going to hit reset because it actually defaults to 40. So in this case, it's 80 and it's DIO. And now we must load up the files, and these are our files that we had on the other one. So we have in the build folder, so we navigate to the build folder of our application. So wherever it is, and it will remember the last place you were. So here's our Hovio. This is our executable, but I'm actually going to do it in this order. It shouldn't matter. It doesn't matter, but let's keep it in order. So we're going to go bootloader, and we put that file in, and we now put the offset in here, and this was 0x1234. Next file was the partition table, and we open that and we put the offset in, and the offset for the partition table was 8000 hex 0x8123. And then the next one and the last one is our application itself, which is in the root of the build folder, and that was at hex 10,000. So that's 0x1023. Now here's something interesting. We don't need that anymore. It's added these, it's changed these files, but it hasn't actually added them. You still then have to go back and click. So don't forget that stage. This is so important. Obviously, it will go through the flashing, but it just won't flash them with the binaries. So I've clicked all those 3, 0, 8, 1000, 10,000. I then select my serial port that the ESP is on and its baud rate. You can try a faster baud rate. I'm just going to stick to the default one, and you hit start. And if the COM port opens, you can see this. It's doing some stuff, and it's flashing away. And away it goes, and it doesn't take that long to flash up. And this is a 16 meg chip. There is also an erase option you can see here, and it says finished. So I'm just going to close that down there now. And what we're going to do is I'm going to open up my terminal to make sure that it is working. And there it boots. And it's the exact same output as we got before. So that's it. It has been flashed and it has booted up. Now, what's great about this is if you come back into your code and you make some edit, once you don't go in and change the partition table or the boot loader or anything, which you probably won't. So if you're just making d whatever, when you compile again, the only file that you need to actually redo is the binary one. And I'm just going to open up our programming tool again. I'll just open this up. And again, I'm going to select S3. And again, I'm going to stay in develop mode. So if we've changed any code, The only one that we really need to do again is this one. So that can be quite handy. You don't have to flash all these. It's much of a muchness. It doesn't take that amount of time. Okay, so that's all there is to it. But there is one other thing I just want to look at. So far we have selected the develop mode. What's the other option? Well, this can be very, 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 very handy. So what you do is you select develop and you go to factory and you open it up. And what this gives you is the ability to flash over several COM ports, several devices at the same time. So you obviously, well, is it obvious? No, but it's going to be the same binaries that has to go to each one. So you will have to select them. But the beauty of this is you can actually start. Oh, it actually has to be the binaries that you previously loaded as well. So you can see, and it'll show a pass or a fail for each one. Each one has its own individual COM port, obviously, and baud rate for the COM port. And yeah, you can flash multiple ones at the same time. You can also lock settings, unlock UI. So here we go. So this lets us select it. So we go through the same process again. We select where our code, our binaries are. So I need to go to my repos, and I need to select my file that I'm working on, and I need to select build. Bootloader is the first one, so we'd select bootloader, and we put in our offset again 0x1234. We then select our partition table, and it's going to go back because I haven't used it since I've installed 3.94. It's going to go through the first the three of them. So again, we're going to go here. We're going to go and this is partition table, and this is at 8,000, and we then select our last one, and again we have to go back to our source code, and this is our actual binary that we're executing, and this was at 10,000 hex. Then we have to select, and we would then configure each one of these that we wanted. We could actually lock the UI then, if that should be 80 megs. We could lock the UI, and then the advantage of locking the UI is if you had 100 of these to do, you could just start them off and get somebody else to check on them. So you'd select each COM port in turn, and you would start flashing it away, and you'd hit start all. So that's it. So that's a very handy tool to let you program the same binaries into multiple chips. Obviously, they all have to be S3s. They all have to be the same chip. They all have to be the same binaries. But if you were doing a production run and you needed to program 8 of these devices, and you had 8 US serial ports and you had it all set up, you could have a nice little production run of these. So that's it. The reason I wanted to do this video is it's handy, but I am going to work on this board, the Kinconi board, and this comes with its own flash on it, and I'm going to be taking that off. But if you want to put back the original flash on this, you'll need to know how to do this, because the people who make this have on their website the firmware for this, and also they have a video about the firmware and about how to upload the firmware. But I just wanted to do one that's going to complement this. So that's the reason I wanted to do it. Although it's very, very handy if you want to keep a build folder of your binaries that are out in the field, and you want to be just able to flash them up on a laptop or on a device that you don't have to install Visual Studio Code and have all the updates and have everything. You just can create your binaries. And what I do is I create my binaries on this machine, and then through Google Drive, I upload those 3 files and a notepad file saying, hey, the settings for this micro are blah, 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 blah. Here's the 3 binaries, and I put that up on my Google Drive. And then it means, and I also put a link to where the install are to the file, the installer for this software. And then it means if I'm off somewhere and I suddenly need to grab a laptop and I need to flash a device, I can actually just download the tool, install the tool. It's a very small memory it takes up, and run the install with the binaries that are available there. I don't have to have Visual Studio Code on every single laptop. Okay, hopefully that's has been of use to you, and we'll see you next time when we actually do some code. Take care, be good.